Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. Today's video comes from OpenAI. Joining us is Erica, a solutions engineer. Her topic is prompt caching, a mechanism that can reduce both latency and cost by up to 90% without degrading model output quality. The technical requirements are precise, and the architectural implications are significant. AI development operates under three persistent constraints: intelligence, latency, and cost. OpenAI's presentation on prompt caching addresses two of these directly, claiming zero degradation to the third. The mechanism is compute reuse. When a model processes a request, it can store the internal state generated from identical prefix tokens, system prompts, images, or prior conversation history. Subsequent requests with that same prefix skip recomputation and process only the new tokens. OpenAI's position is that because model parameters are deterministic, an identical prefix produces an identical internal state. There is no intelligence penalty. The only variables affected are cost and speed. The cost reduction is substantial. For GPT-4o, cached input tokens receive a 50% discount. For GPT-4 Turbo, the discount is 75%. For the GPT-5 model family, it reaches 90%. Audio caching on speech-to-speech models shows discounts approaching 99%. However, the first architectural constraint emerges immediately. Caching activates only when a prompt exceeds 1,024 tokens. A prompt of 900 tokens generates zero cache benefit. The presentation included a test case where expanding a 900 token prompt slightly beyond the threshold, combined with a 50% cache hit rate, produced a 33% reduction in token costs. Even with a sufficiently long prompt, the system exhibits extreme sensitivity. The cache depends on a contiguous, identical prefix. Routing decisions are determined by a hash of the first 256 tokens. Any modification at the beginning of the prompt, a timestamp, a dynamic user identifier, or even extraneous whitespace invalidates the cache for that request. The discount collapses from 90% to zero. The presentation noted that customers have inadvertently introduced such changes and eliminated their cost savings entirely. This introduces the prompt cache key, an optional parameter functioning as a routing directive. Without it, thousands of identical requests are distributed across different machines, fragmenting the cache and reducing hit rates. Providing a prompt cache key groups related requests to the same engine, a coding customer saw their cache hit rate increase from 60% to 87% after implementing this parameter. Warp, a company developing an agentic development environment, applied this more aggressively. Their cache hit rate more than doubled following effective use of the prompt cache key. Their design strategy involved organizing the cache into scopes, a global scope for the system prompt, a user scope for individual configurations, and a task scope for turn-by-turn agent work. All dynamic content was removed from the main system prompt to maintain cache integrity. API endpoint selection also affects cache performance. For reasoning models, switching from the chat completions API to the responses API can double the cache rate. One example showed an increase from approximately 40% to 80%. The difference is that the responses API retains the model's hidden chain of thought tokens, while chat completions discards them, breaking the cache on subsequent turns. The default cache persists only 5 to 10 minutes in memory. Extended prompt caching extends this to 24 hours by storing the cache in GPU local storage. For very long prompts, this feature reduces latency to the first token by 67%. A coding customer using extended prompt caching saved up to 20% on input tokens. This creates a design tension. Prompt caching requires stability. Effective agent design often requires dynamic context engineering to improve accuracy. The presentation made the point explicit. Invalidating the cache on every request to manage context becomes prohibitively expensive. The recommended approach involves less frequent, larger compactions or using parameters like retention ratio to make bigger cuts less often rather than naive per-turn truncation. For advanced use cases, there is another optimization tool. Normally, modifying the tools available to a model invalidates the cache because tools are part of the prefix. However, the allowed tools parameter is excluded from the prefix hash. This permits dynamic tool selection on a per-request basis while preserving the cache. The presentation's conclusion is direct. Prompt caching is not an optional optimization, it is a foundational architectural decision. The potential for cost and latency reduction is significant, with savings reaching 90% or higher. Achieving these savings requires precise understanding of the mechanics, the 1024 token threshold, the requirement for a stable prefix, and the strategic application of tools like the prompt cache key and endpoint selection. If you're interested in the video featured in this episode, click the link below to watch the original.